Welcome to the Alpha Training and Consulting's online training program. Today we'll answer the question, what is a Poisson distribution? A very good question, very important one to be able to answer in the world of quality engineering and Six Sigma. Please keep us in mind should you ever have a need for ASQ certification preparation training. We've been doing it for 20 years and we've become very good at it, and we'd be honored to have you as a student. So please keep us in mind. Now back to the question, what is a Poisson distribution? We're going to explain that by doing an example problem. Now the key word for Poisson distribution is defects. For binomial, which we've discussed earlier, it was defectives. So there's a difference between defectives and defects. Defectives means you violated a spec limit. It's a bad part. Defect is a flaw. A flaw. No matter what I buy, I could look at this pen brand new right out of the box. I'm sure I could find something. There's a little scratch right there. It's a defect. Do I really care? No, I wouldn't even noticed it had I not been looking for it. I don't really care. And so remember, that is a defect, is a flaw. Flaw. Now you get enough flaws and it could become defective. Okay? But the Poisson distribution is used to model flaws. And whenever you say flaws or defects, you must say defects per. So Poisson models a rate per, defects per part, defects per square foot, etc. Those are all key words for the Poisson distribution. So let's read this problem statement and see if you can pick up on the key words suggesting that this is a Poisson distribution problem. A process produces sheets of glass. The average defects, there it is, defects per. Bang! You've got the right, you know this is Poisson right there. Defects per sheet of glass are 5. It could also say flaws per sheet, by the way, they mean the same thing, are 5. What are the odds that you will pull a sheet of glass and find exactly 7 defects? Okay, they only gave us 2 numbers, the average and the number they're interested in. The average is 5, then we'll need that 7 here in a little bit too. How do you use it? Well, it's pretty easy. This is the Poisson table. You go to the mean, which remember was 5. Let's go back there. Average defects per sheet of glass are 5. There's the mean, 5. Okay. And then you go over how many are you looking for. They call that X on this table. It's 7. Remember, they want to know the probability of finding exactly 7. And so there's the 7. Where this row and that column intersect, that's the probability of that situation taking place, which is 10.44 in this case, 10.44%. Probability that if the mean is 5, then the probability of getting 7 is 10.44. So the odds of picking a sheet of glass with exactly 7 defects is 10.44, as it says there. If it said 7 or less, you'd add all these up, and that'd give you the probability of 7 or less. If they said 7 or greater, you'd add 7 or greater. Add all those up to get those probabilities. But that is the Poisson distribution. Very powerful distribution when you're working with flaws or defects. So let's read this. This is a real-life example, and see if you can pick up that this is indeed a Poisson distribution problem. The glass disc is divided into 12 equal sectors. During a visual test, we found no sector had 0 defects. Okay, there's the key word there, defects. 4 defects were found in 4 different sectors. 3 defects were found in 2 different sectors. 2 defects were found in 4 different sectors. 1 defect was found in 2 sectors. Would you consider this distribution of defects per sector to be random? Okay, so this was something I used as in the real world, so I thought I'd throw that up there. There's the formula for the Poisson, but usually we just go right to the Poisson table, but it's mean to the R power, R meaning the number of defectives. Oops, that's a typo, isn't it? Number of defects, it should say. E to the power of the negative mean, and R factorial. But again, usually you'll use the tables on that or a computer program. All right, I hope you learned something new that will enhance your career. Remember, if you have any need for ASQ certification preparation training, please keep us in mind. Thank you and have a great day. Goodbye.